Hi children. Hi. So nature and position of the images. Nature and position of the image is formed by the concave mirror. A concave mirror is one whose polished surface is away from its center of curvature. Center of curvature is a point by which a part of sphere is formed. So this side is unpolished surface. Always we keep the object that is in front of unpolished surface, before the mirror, behind the mirror. We call this as behind the mirror. Behind the mirror it is polished. Before the mirror it is unpolished. So an object can be placed before the mirror. When you turn this mirror towards a distant object like an electric pole, when we turn this mirror towards a distant object like an electric pole, the image of the electric pole can be formed at the focus. The image of the electric pole is formed at the focus. How exactly it is forming? You see here, this is an object. When the mirror is turned towards an object, the rays which are coming from this object, straight object, are parallel. This is one incident light ray, this is another incident light ray. So these two light rays are parallel to each other. When the rays are parallel to each other, incident rays, and incident on the mirror, maximum part of light is bounced back into the same medium. So these two are reflecting rays. The reflecting rays are converging to the point F. The point at which these rays are converging is called what? The principal focus of the mirror, where you can say the image is formed. Image is formed. Now this is an image formed. This image can be caught on the screen. If you place a screen here, you can easily see the image of the object here. This is a point image. Very small image can be seen. Highly diminished image is formed. That's why in the first case, when object is kept at infinite distance, this is an object kept at infinite distance, the final, real, highly diminished, inverted image is formed. Final, real, highly diminished, inverted image is formed at the focus of the mirror. This everyone has to remember this. Whenever an object is placed at infinite distance, a real inverted, highly diminished image can be formed on the same site but at the focus. That image can be caught on screen because it is formed by the convergence of these two reflecting light rays. Hence this image is called a real image. All real images are always inverted in nature. So this is the first case. Children, one more thing. If you want to know the focal length of the given mirror by using this distant object method, what is the name of the method? Distant object method. We can find out the focal length of this mirror. Focal length of the mirror, that is distance of the focus from the pole of the mirror, is called focal length. The focal length can be measured, whose magnitude is very small, usually in a few centimeters, of course. So only thing is you have to do, just turn the mirror towards a distant object, and the rays which are coming from the distant object are incident on the mirror, and afterwards these reflecting rays are converging to one point where you can just place a plain white paper so that the image can be seen here. So measure this distance. If you measure this distance, you will get, with the help of a scale, we will get distance of the focus, distance of the image from the pole. That distance of the image itself is called what? Focal length. When object distance is infinity, image can be formed at focus. Please write down always. This is the first case. When object is kept at infinity, the final, real, highly diminished, inverted image is formed at the focus of the mirror, as shown in the figure. Everyone has to draw the figure. This is principal axis, this is first incident light ray, this is second incident light ray. You can also imagine one more incident ray in the direction of principal axis. All these three rays, the ray that is incident on the principal axis makes an angle 90 degrees, it retraces its path. That means it will go back like this. Travels and strikes the mirror and bounces back. These three light rays are called convergent reflecting light rays. They are converging at one point called principal focus. Please note. See, write the second case. In the second case, children, please write down. It's a very interesting case as everyone has to remember. This based on that problems will be there. An object is kept between C and F. An object is kept between C and F, not F, between C and infinity. The object is kept between C and infinity. This is what infinity. This is what C. When an object is placed between C and infinity, this is an object. So, when an object is placed, a wire mesh is illuminated by a source of light and that wire mesh is kept here. So, the image of this wire mesh can be seen between center of curvature and focus, because this is an incident light ray proceeding from that object and is reflected like this. Another ray is traveling through center of curvature. Remember, this is a rule for forming the image in this case. The rule for forming the image is the second ray that is traveling through center of curvature will make an angle 90 degrees here. It makes an angle 90 degrees. This is called normal incidence. So it is incident on this ray at an angle 90 degrees so that it retraces its path. It is now retracing its path. So it is going back like this. This is one reflecting ray. This is another reflecting right ray. So these two are converging at this point, forming an image. Children, I said this is what we call, for this mirror, you can imagine a normal here. This is called normal incidence. Normal incidence means it is in the direction of the normal. When the incident ray is in the direction of the normal, the angle of incidence must be equals to what? 0. And the nature of incidence is called what? Normal incidence, because it is making an angle 90 degrees with the surface of the mirror. It makes an angle 90 degrees with the surface of the mirror. These two will be, that is 90 degrees, this is 90 degrees. But the incident ray will be in the direction of what? The normal. For this mirror, this could be the normal. When the incident ray is traveling in the direction of the normal, so the angle between the incident ray and the normal will be equals to 0. When the angle of incidence is 0, the nature of the incidence is called normal incidence. This is called normal incidence. So we need to consider two rays. One ray is parallel to the principal axis. Another ray is traveling to what? The normal at the center of curvature. So it makes an angle 90 degrees on the surface of the mirror. So bounces back. These two convergent rays are convergent at this point, forming an image. And if you draw a normal to this principal axis, that gives the size of the image. IM is the size of the image. OB is the size of the object. Size of the image divided by size of the object is of course magnification. The magnification value is also less than 1 here, because size of the image is less than the size of the object. Hence magnification is less than 1. So here distance of the object is less than infinity and distance of the image will be more than focal length. It is more than focal length. Distance of the image is what? More than focal length. As you reduce the distance of the object from infinity to what? A distance that is less than infinity, the image distance is increased from focal length to a distance that is more than focal length. This is case number 2. That's why a real inverted diminished image, not highly diminished, but it is diminished image formed between F and C. F and C. Size of the image is increasing, distance of the image is increasing, magnification is also increasing. Earlier it was highly diminished, now it is a diminished image. So magnification is slightly increasing as we reduce the distance of the object. Distance of the image will be increased. So ratio of distance of image to the distance of the object called magnification. Magnification is increasing. Please note down. Okay, it's interesting. Diagrams are very interesting. So you need to draw the diagrams. So you need to have a scale and pencil, eraser, sharpener. You should keep. This is geometrical physics, geometrical optics. In geometrical optics, we need to draw so many diagrams. Ray diagrams must be drawn. So we need to keep one scale and pencil. Of course, practice chega, you will be habituated for drawing these diagrams. Case number 3. Now I wanted to reduce further the distance of the object. Now the object is kept at center of curvature. The object is kept at center of curvature from the pole of the mirror. As we keep the distance of the object as equals to radius of curvature, and when it is kept, okay ma, when it is kept at a distance that is equals to radius of curvature, so what is going to happen? You see, this object, when it is kept at center of curvature, so what is going to happen? You need to consider two incident light rays. One is parallel to the principal axis, that is now traveling through focus. Another ray is traveling through focus, and when the ray is traveling through focus, it is now bounced back parallel to the principal axis. A ray that is parallel to the principal axis is traveling through focus. This is traveling through focus. This ray is traveling through focus. Like this, it is traveling through focus. Yes, coming. So another ray that is traveling through focus is now rendered, that is bounced back parallel to the principal axis. It is now bounced back to the parallel to the principal axis. This is one reflected ray, this is another reflected ray. These two reflecting rays are converging at this point, and this gives the size of the image. The size of the image is given by what? Im. So the same size of image is formed as that of the object at the same distance. Object is kept at a distance equals to radius of curvature. Image is also formed at the radius of curvature. Therefore, the magnification is size of the image by size of the object. Hence, magnification must be equals to what? 1. It must be equals to 1. Okay, thank you. అమ్మాయి కొంచెం వాటర్ తెస్తా. So these three cases are very important. Another three cases are there. Object is kept between center of curvature and focus, that is fourth case. And object is kept at principal focus, that is fifth case. When object is kept between principal focus and the pole of the mirror, that is sixth case. So now let us discuss those three cases also. First three cases everyone has to practice. Object is at infinity, image is at focus. Object is between infinity and center of curvature, image will be between center of curvature and focus. Object is at center of curvature, image is again formed at the center of curvature. These three cases everyone has to understand. See, I am repeating again. Object is at infinity, image will be formed at principal focus. So it is the real image, inverted image, highly diminished image. And this is when object is kept between center of curvature and principal focus, infinity, center of curvature and infinity. This is what we call, see, this is a diminished image, not highly diminished, but it is a diminished image. A real inverted diminished image is found between center of curvature and principal focus. In the third case, when object is kept at center of curvature, the same size of image is formed again at the center of curvature. Children, you understand? Do you find some interest in it? Please practice. Each diagram you have to practice at least twice, thrice, 4 times, 5 times. You should take the interest so that you will be habituated to draw these diagrams very well. So everyone has to practice. Take pencil, scale, paper, and you please draw these diagrams. Thank you.